All right, morning guys. This is Komucho Munyai here. So I'm gonna share with you this problem that grade 11 and 12 have been having. Last Sunday, this past Sunday, it was our first session, so we did trigonometry. Okay, so let's dive into the problem. So here we have a problem, a trigonometric equation or problem. This is my first maths tutorial, so I just want you guys to tell me how you think of the video and as we move forward. So the question says, if sine 12 degrees equals to p, write each of the following in terms of p. Remember, when they say in terms of p, they mean your answer must have p on it. So it can either be 1 plus p, 1 minus p. So your answer must have p in terms of p. Understand? Okay, so let's proceed. The first one, it says sine 168. So sine 168, we know 168 falls into the second quadrant. It falls into the second quadrant. Now, we want to reduce this 168. We want to use reduction formula. You have to use the reduction formula in order for us to get the answer. But first, I would advise you to have all the three parameters, x, y, and r. And then also have this diagram. This diagram shows the angle here. You must at least have this diagram so that you don't get confused. You understand? So you have 0 degrees here, 90 degrees, 180 degrees, and 270 degrees. Okay, lastly is 360 degrees. Those are the special angles on this Cartesian plane. So on this triangle, I have my angle. I have from the given problem here, it says sine 12 equals to p. So it means sine at 12 degrees, only at 12 degrees, it has p and x. So these two, one of them is known, one of them is unknown. We don't have x, we only have y, because sine of any angle is equals to y over r. So our y here is going to be p and our r is going to be 1, because we are given that sine 12 equals to p. So here, okay, the first thing I wanted us to do is the third parameter, which is x. This one, harne x. So the only way to get x is to use Pythagoras theorem, because we have a right angled triangle, you see, and we have two sides, and the last side it's x. So Pythagoras theorem states that r squared equals to x squared plus y squared, and then we replace. Our r is 1, our x is unknown, and then our y is p, which is squared here, and then we're going to have 1 equals to x squared plus p squared. So how do we agree? We want to solve x, so we have to move this p squared on the left hand side. So moving it, that means we want to use the opposite of p squared, which is going to be minus p squared on both sides. Remember to do it on both sides. Everything you do with maths, you do on what you do on the left, you also do on the right. This one cancels this one. Okay, this one cancels this one, and then we're going to be left with x squared this side, and this side is going to be 1 minus p squared. So it's like this, x squared equals 1 minus p squared. So a lot of people, they just see this this squared being removed to the other side, but they don't understand how to do it exactly and what it means. Okay, so let me tell you. If you multiply by 1 over 2 on both sides, here you will remain with only the exponent of 1. And then our x is going to be the square root of 1 minus p squared, which is plus or minus. The reason why we put plus or minus is because we are not sure whether this x was negative or positive. Because when you multiply minus x by minus x, you get x squared. When you multiply x by x, you also get x squared. So you can never be sure of your x, which one, is it negative or is it positive, unless you use a diagram. Unless from the diagram. So because from the diagram we can see that our x is supposed to be positive, therefore x equals to the square root of 1 minus p squared, not negative. Understood? So this is how we get our x. So going back to the first one, we use reduction formula. So it's sine into 180 degrees minus 12. So 180 degrees, we have 180 here, 180 is here, so we minus 12. We fall into the second quadrant where sine is positive. So it's sine 12. And then from the question we are given that sine 12 equals to p. That means we replace this sine 12 with p. I hope this one is clear. And the second one, it says 1 over sine 192 degrees. So this one, we also use reduction formula on this one. So it's going to be sine into 180 plus 12 to give us 192. So I hope this one is clear and you can see everything going on here. As long as you have your ratios, all of them, you have all your parameters x, y, and r, so you won't be having a problem solving here. Okay, so 180 plus 12 degrees. So we are falling into the third quadrant where y is this one. This y is going to be negative here, because y is negative from here going down, it's negative. X is negative from here going to the left. So our sign is going to be, so I'm going to write 1 minus 1 over negative sine, and then into this one, sine it's negative, that's why I put a negative here, and then I write 12. So from the question we are given that sine 12 degrees, it's p. So that means our answer is going to be minus 1 over p. We replace that sine 12 with p. So this is how you solve this kind of problems. So even if you have a cos, let me say cos 12. Okay, let me just write this one, cos 12. So with cos 12, because we know the value of x at 12 degrees, we know the value of x. The value of x at 12 degrees, we calculate it as the square root of 1 minus p squared. That means x is going